everybody, today we're looking at permutations versus combinations, and I'm going to use the Winter Olympics men hockey as our example. In the 2026 Winter Olympics in Milano, there are a total of 12 men's ice hockey teams. The 12 teams are split into 3 groups, A, B, and C, for the preliminary round. During this round robin, teams play every other team in their group once. After 3 games, all 12 teams are ranked. The top 4 teams, which are the 3 group winners and the best runner-up, receive a bye directly into the quarterfinals. We're going to use this information to answer a couple of questions. Our first question is, how many ways can the bye occur? And remember, this is 4 of the 12 teams. We're also going to calculate how many ways gold, silver, and bronze can be awarded. Let's start by calculating how many ways the bye can occur. So let's start with this question. For the bye, does order matter? Thinking, we're grabbing 4 of the 12 teams. And the answer is order doesn't matter. When order doesn't matter and repetition is not allowed, we can use a combination. Because we have 12 teams and we're trying to pick 4, we would write this as a combination of 12 choose 4. Let me show you how to do that calculation in Desmos. In Desmos, you can open the keypad, go to Functions, and scroll down until you find Number Theory. On Number Theory, you're looking for NCR to show we have a combination. Pay attention to the notation it puts in. This could be a nice shortcut for you if you're doing a lot of combinations later and you don't want to have to go through the keypad and functions each time. We need to put in how many teams we have, 12, comma 4. This gives us 495. This says there are 495 ways that 4 of the 12 teams can go directly through the quarterfinals from the first round robin group. Now let's calculate how many ways gold, silver, and bronze can be awarded. Remember, here we're referring to all 12 teams. So for the medals, you need to ask yourself the question of whether or not order matters. And this time the answer is yes. We know there's a difference between gold, silver, and bronze. Because order matters, we need to use a permutation. So we go back to our 12 teams, we use P for permutation, and then we're choosing 3 to represent gold, silver, and bronze. Let's go back to Desmos. In Desmos, you can again open the keypad, go to the functions, and scroll down to find Number Theory and then Permutation. Enter 12, 3, which gives us 1,320. The 1,320 tells us the total ways gold, silver, and bronze can occur. Combinations and permutations are only used when repetition is not allowed. We use a combination whenever order doesn't matter, and we use a permutation anytime that order does matter.